Hi guys, welcome back. Today on the bench we have this Hitachi TRK-3D8 boombox radio cassette from 1986. This is almost too big to get into shot. Let me push it back a bit. So this is a twin deck radio cassette. It has a 3D superwoofer, which you can see the Hitachi models of the time. A lot of them had the 3D superwoofer. There were different sizes. Some of them had two in the center, some of them had a rectangular speaker in the center, but a lot of them had that, and that was the selling point for this, the 3D part. 3D just meant that it had a subwoofer. So a lot of the radio cassettes at the time just had the full range speakers, stereo speakers, maybe a little bit bigger than this, but they had the full range speaker. This one has slightly smaller speakers, but it also comes with the subwoofer as well, or superwoofer as it's called on this. And this is just for the low frequency notes, so both channels will route via the amplifier to this single center speaker here. And there's a switch on the top that you can switch it on and off with. Let me just quickly show you around this. I haven't done any work on this yet. This is as it came to me, so there's a few marks on the grill. The case is dirty still. You can see here there's dirt in the switches, so it all needs cleaning up. There's also a number of faults with this as well. So this was sold to me as a non-working box, and the deck 1, so this deck does work, deck 2 does not work. When you press play on this, the reels just don't turn round. It's probably the old belt issue with this. Deck 1 works, and the radio doesn't work either. So when you turn this, in fact the dial itself is broken, because there should be an indicator slider that moves along in this window here. It's driven by a belt or a piece of nylon string that goes around the pulleys, and this just isn't doing anything. So as I said, I haven't opened this up yet, but to be honest, I'm not too bothered about those faults, because I had another project in mind for this. As you've seen from the video title, I want to incorporate, well, it's going to be an Amazon Echo device into this. The advantage of this particular stereo is that it has a line in. So you can see there, CD line in, and around the back there's two phono inputs, stereo phono inputs. So this should be fairly easy to integrate that device into. I initially thought, as I'm a Google Home owner, so I've always had Google Homes rather than the Amazon Alexa, and the Google Homes I was going to incorporate into this. And one of the issues that I immediately saw was that it didn't have a line output. So none of the Google Home devices have a line out or a headphone out or anything like that. They just have the internal speaker. Now I've seen online there's a number of videos that show people that have hacked that speaker output. They've put some resistor network on there and been able to route that to a line out. One of the other problems is that speaker is only a mono speaker. It's both channels combined, but it's just a single mono output. So if I was to do that, if I was to get the Google Home, put the resistors on, create a pseudo line out, when I input it into this box, I would only get a mono sound. So I could route it to both speakers. It would come out of both, but it would just be the same channel, same mono channel. So I then thought that I would pair two up, because with Google Homes you can pair two together and route left and right channels to each device. So you're meant to put them in opposite sides of the room, and you get a left and a right stereo channel. So that is possible. I could have done that. But then I discovered that the Amazon Echo devices, I've got one here. This is an Amazon Echo Dot, second generation. They've done a number of generations. I think they're up to 4 or 5 or 6 now. And as far as I'm aware, I don't know much about the Amazons. I'm more of a Google guy. But as far as I'm aware, the upgrade in different generations of Echo Dot are primarily just a better speaker inside here. Now, I'm not using that because I want to route the sound through to this speaker system. Now the advantage of these is that it comes with a line out, and it's a stereo line out. So a normal 3.5mm jack, plug it into there, and instead of the internal speaker we have our line out here, nice and easy. So that is what I'm intending to do in this video. I'm not sure how well it's going to go, but we will give it a try. So what I'd like to do, not just routing the audio through to here, this, as the Google Homes and the Amazons are all the same, they have some LEDs on the top. This one is in this clear ring here. There are a number of RGB LEDs that run round. In fact, let me just plug it in for you and you can take a look. And the LEDs, they kind of indicate what the thing is doing. So at the moment, they're lighting up blue. Let me just turn that light off. They're lighting up blue, and it's just to indicate that the thing is starting up at the moment. But they can go red or orange or just flash different colors depending on what's happening, whether it's interpreting some voice commands or whether it's you're muting the microphone or it's updating or something. So I thought it'd be quite nice to remotely mount these LEDs inside the front of this box somewhere, maybe on this strip here, or perhaps in the cassette window or somewhere. I'm thinking it might be a nice idea to do that. So that's what this video is about. It's about incorporating this into the box. So things to think about are the power supply for this. This is USB input, so it's 5 volts. This box runs off 12 volts. It's either 8 D-cell batteries or a 12 volt input, or the mains input to this will rectify and reduce that power down to 12 volts as well. So the thing runs on 12, so that we know there's 12 volts in there. It should be easy enough to put a 5 volt regulator in there as well and route the power to this. So what I'm hoping is that we can just, the moment the deck is off, because in the tape position here, these decks are always off, so it says off or tape, and it's not until you press play on the tape deck that the thing will power on. So I'm pressing play here and the unit is switched on. Other than that, we've got the CD line, which is also will switch the power on. So if you look at the operation light there, again that's switched on there in the CD line input. And then we have the radio as well. Let me just turn that down because it's probably going to be loud. That's the radio position. The problem with the radio, as I said, there's no way of tuning it at the moment. But I don't know how far I'm going to go with the repairs on this because I want to primarily use this Amazon Echo inside it, and I'll put it on the line input. So we'll switch this on. It will power the box and power this unit as well. When it's paired, it will automatically pair and connect to the internet where I am. So it should be good to go. Other things to think about, there are the RGB LEDs, of course, that I'd want remote positioning somewhere. If it's going to be too difficult, I might not do that, but I'd like to do that. The 4 buttons on the front here, at least when you're repairing this to a new Wi-Fi, you do need to press these buttons, so I can't get rid of these altogether. So I might mount some 4 little tactile switches on the back of this unit, or maybe at the side, maybe on the front. I haven't decided yet. And the microphones are within here, so when you talk, this obviously picks up your voice. Now there's one microphone in the center, and there are a number of microphones around this ring here. So I need to mount this somewhere, or mount the microphones somewhere that they're still going to be heard from this Amazon Dot when somebody speaks. Now, like I said, I haven't opened this up yet, but looking at the side, there's a grill here, and if you look in the grill, you can see right through the device to the other side. So this is an open grill. So I'm wondering whether the microphones could be mounted behind that grill, perhaps. It's only going to be on one side, so perhaps the reception might not be too good, but we can try that out. I'll just show you the back while it's here. There's the line input. So with the Amazon Echo inside this, incorporated inside the device, I'm obviously not going to use these sockets here. I will wire it internally. But it'd be quite cool, I think, to run this off batteries. No wires at all, and it's got the Amazon Echo in there, so you can take it outside in the garden if you're outside, and you can just talk to it and request the songs that you want. So that is the plan. Like I said, I'm not sure how far I'm going to go with the repairs on here. I could repair the radio and the tape as well and have the fully functional box as well as the Echo inside, but I think on this video we're just going to concentrate on incorporating the Amazon Echo into this. So that's what it's going to be about. So the first thing I'm going to need to do is open this Amazon Echo up and see what is involved in incorporating this into the Hitachi box. So I've seen a teardown of one of these online already, and I know that there are some screws holding this together under this panel at the bottom. The videos I've seen talk about heating this up to be able to get this pad off the bottom off completely in one piece without damaging it, but as this won't be seen anymore, this will be, in fact it probably won't have the case at all when it's inside the radio cassette. I'm not bothered about a destructive tear down here. Yeah, like the rubber's come off, but the adhesive pad here has remained behind. Let's try and get that off. Torx screws. So the whole lot just tips out. I think this bit here is the speakers themselves. I can see two contacts on there, so I'm imagining this is the speaker. Not sure how that comes out right at the moment, but I'm not too bothered. I'm not going to be using these speakers anyway. This is the part we're interested in. So looks like two circuit boards. Top one with the buttons, and I guess the main circuit at the bottom there. So it's a flat flex. Disconnect that from here. Looks like it's just fits in here. I don't think there's a release. Yeah, it just presses in that one. Plastic frame, rubber mat. So I'm not sure how warm these get. This looks like it's some sort of heatsink for perhaps some ICs on the other side. I'll have to have a look at that. If necessary, I'll just incorporate this whole thing into the Hitachi. Now, this part here, there's no more screws in this by the look of it, it's just all press fit. So the switches are tactile domes on this side. And on the other side, does this come off as well? This looks like some sort of foam pad. It's glued on that. Okay, so the 4 buttons here, they're just single pole switches, so we can wire them off to whatever switches we want on the side of our case. This side, we have microphones. So there are a number of microphones, 1, 2, 3, 4, 5, 6, and 1 in the center, so 7 microphones. And these are our RGB LEDs. So it should be easy enough to unsolder these LEDs. I probably won't use these. There's no point using these tiny LEDs because I want them on the front of the box. So I want them to look a little bit old school. So I'll probably go with a 5mm or 3mm RGB LED and mount them in a row on the front rather than a circle. I could put them in a circle around the speaker. I'm not sure if that would look a bit strange though. I want it to look smart as well, so I may get some RGB LEDs, put them in a line, and see what that looks like. And then I can wire them up to this plate, and we'll see what they look like either in a line. If they don't look any good in a line, I might put them in a circle. But yeah, it'd be nice to have those on the front of the box. So let me get some of those ordered, and I will come back. I've got some RGB LEDs now. These are 5mm I decided to go with, which is just 3 separate chips inside that LED. So the next thing to do is to take the LEDs off this board and run some wires off the board so I can mount these remotely wherever I decide to on that case. The microphones themselves are around the edge here, but the sound goes in through these little holes on the reverse side. So if I'm going to mount this to the case where there's either a hole drilled or maybe in that grill that I mentioned, I'm going to mount this side towards the outside of the case so the wires can all come off on this side without obstructing those microphones. I don't think it's worth mounting these microphones remotely as well. So before I take these LEDs off and put the wires on, let me just show you the LEDs on this board. I'll turn this light off and you can see what they look like without the diffusing ring. So they're very bright. I'm hoping that the ones I bought are equally as bright as this. So this is its startup routine. As soon as you apply the power, this is what the LEDs look like. And that's it, it's ready to use. So if I say the wake up word, Alexa, we can see there that has woken up. So what I'll do now is I'll run some wires from the board to these LEDs. There's 12 in total. So the common are just need one wire linking all of the LEDs together, and then there'll be 3 extra wires for each LED from the board, so that's 36 wires in total. So it's going to look a bit messy. There's going to be 36 wires coming off here, but I'm not really bothered what it looks like as long as it works. And those microphones, as I said, on the back are clear, so it's not going to interfere with those. I also need to solder on some connection wires for these switches as well. So I will go and do that, and then I'll show you what that looks like. So I've soldered these cables onto the Amazon Echo Dot. You can see that I'm using a ribbon cable here, and I've split it up into groups of 3. So each of the 12 spaces here that had the RGB LED on, I've now soldered 3 cables. So all of these cables I've brought back onto a breadboard so I can show you the LED lights. Now these LEDs were really small, tiny LEDs they were, and it took a bit of soldering onto these wires, onto the pads. So first of all I removed the LED, cleaned up the solder pads. I'll put some pictures up here of what they look like when I was doing it, and then I've soldered on the 3 wires. Now the LEDs themselves, they've got 5 pads. One of them is the common anode, so that's the one at the top. And then moving across, we've got the blue LED, which is on the left hand side. And then the center pin at the bottom is the red LED. And then the one on the right is the green LED. Now there are 2 more pads at the top of the LED, but they were a duplicate chip for the blue and the green. So the red, there's just one chip on these particular RGB LEDs. There's a red chip, and then there's 2 blues and there's 2 greens, but they're just commoned up on the board. So we only need 3 wires onto each of those. So that's the way I've soldered them. Now if we move across to the breadboard I've got here, what I initially did, as I said previously, I wanted to use RGB LEDs, and I've got one here wired in. So there's 12 LEDs, 12 channels coming across here from left to right. And I initially put in all RGB LEDs to see what they'd look like. I've got a little video I'll just put over the top here. Now, whilst that worked, and it worked exactly the same way as the ring of lights on the Alexa did, I don't think that's going to fit in with what I want to do. So I want to put in this Alexa into a retro 1980s boombox, and to have RGB LEDs on the front, I just don't think that's going to look retro enough. I wanted it to sort of be in keeping with the box itself. So what I've decided to do is to use red LEDs only. So these ones here, which are actually coloured red, so the newer red ones are water clear LEDs. I wanted to use these actual coloured red ones that just look a bit better in my opinion as for what I'm trying to do. But just to show you what these look like, I'm going to turn this light off and I'll connect the Alexa up. So what I've got here, I've got the 12 channels. The first channel is just a standard RGB LED, so you can see that lighting up. The second channel I've split into separate RGB lights here, red, green, blue, so that's for channel 2. And then all the other channels, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they're all red LEDs. Now I've put the red LED on the green channel. So when the original Alexa RGB LED lit up green, that's when these red ones will light up. And I've done that because through looking at what the LEDs do when you talk to the Alexa and it's in operation, the green ones seem to be the active LEDs. They light up when there's some activity. So they're the only ones that I'm going to wire up to these red LEDs. The red channel pretty much just comes on when there's a problem with the Wi-Fi or when you've got it on mute, so we're not missing much there. And the blue channel, that doesn't really show anything. They light up blue pretty much all the time, just sort of a base colour, and then the other LEDs on top of that. So I think it will work with just the green ones, but let me show you what it looks like. So I'll plug it in to the power, and then it'll go through its startup routine. If you remember what it looked like before, it was a blue ring, and then there was green LEDs that flashed around in a ring. These ones, it's obviously in a line, but you see it's blue at the moment, and then it flashes on the green LED. So this green one's flashing, that's the second channel, and also the green LED in here, in the RGB LED, that's flashing. So you imagine this is just a line of greens, but also all of the blues are lit up. So the blue there and the blue here, obviously you don't see the blue here because they're just red LEDs. But if you can imagine, this is what it's going to look like on the front of the box, just these red ones. So if I say the wake up word, Alexa, play Spotify. And you can see there they flashed for a moment whilst it was thinking about it, and then they disappeared. So every time there's activity, it's the green ones that light up, and I've put my red LEDs on that green channel. So anytime there's activity, I'm going to see a flicker on the red. So if I give it something to do, let me just plug it into this. I've got a stereo here that this line out is connected up to, so you'll be able to hear what's going on. Oh, it's got some music on there. Alexa, stop. And what I'll do is I'll just give it something to do. Alexa, what is the value of pi to 100 digits?
The first 101 digits of pi, that is pi to 100 decimal places, are 3.14159265358.
So as you can see, once it's doing something, once it's in active mode, these green ones, which are now the red ones, are the ones that are going to flash and do something. Just the blue ones, you can see it's just a constant blue. It's on all the time. Just turn that down. So these blue ones are on all the time. So there's no point having those lit up. And the red ones, as I said, very rarely do you get the red ones on. It's just for mute or if there's an error with the system. So that's what I've decided to do. I'm just going to wire up these red LEDs to the front somewhere, and hopefully that will look quite good. Also, if I did any more of those, I wouldn't need to take all 36 wires off. I just need to take 12 wires just off that green channel if I want to do the same thing again. Maybe if I was incorporating this into a more modern box, I could use the RGBs and use those. But yeah, that's what I'm intending to do. Now this boombox I was going to use, let me just show you this. This is the one here that I was originally showing you guys, and this was the one I was intending to use. I've changed my mind now. I've actually bought another box, and it's this one. And this is the Hitachi 3D80. So the other one is the 3D8, and this is the 3D80. The reason why I've changed my mind is that this one comes with red stereo VU meters on the front, or power level indicators on the front. So when the music is playing, these will flash. I can show you that now actually. Let me just put something on. Alexa, play Spotify. Alexa, volume 10. So there we are, it is playing music now, and you can see these LEDs. So what I'm going to do is mount these other LEDs, the Alexa LEDs, somewhere else. I'm not sure where yet. Probably in this grill, somewhere here, maybe at the bottom. I'll have a little think about that. The next thing that I've done is replace the op-amp. So that's this 8-pin package here. This is operational amplifier, or op-amp, and it's basically acting as a preamplifier. So all of the sources go into the selector switch, and then they're routed through the op-amp. So this then derives the correct level that the amplifier is going to require the power amplifier. So the signals go through here and then go onto the power amp. Now, the op-amp of the day, the op-amp that was in this machine when it was new, so 1986, they're not quite as good as the op-amps you can get now, and that most of them are pin-for-pin compatible. So the one that I've used here, well, the one that was in it originally is a C4558C op-amp, and the one that I've replaced it with is an NE5532P. So the main difference between the two op-amps is the frequency response. It's a much faster op-amp, this one, so the frequency response is better, and you can noticeably hear a difference when you change out that op-amp, and they're very cheap. So if you've got this open, got the circuit out, it's a good upgrade to do on these. So one feature I like of this boombox is the LED display on the front, the LED VU meters. There's 5 red LEDs on each side, and it suggests that this is left and right channel, so you get a stereo VU indication. Now, it's not the case. If you switch off one of the inputs, then both of these displays still light up, and the reason for that is that they are just wired up in series. So there's one IC here, which is a BA6137. This is a 5 LED VU meter, and there's just one of those. It's a mono, there's one input, and each of these LEDs is wired in series with the corresponding one on the other side. So when this one lights, this one lights. So inside the boombox itself, the audio signal is combined before it reaches this board. So this is displaying a combination of left and right, but mirrored on both sides. So what I'd like to do is make this a stereo VU meter, so left and right channels. So I'm going to keep the circuit that's in place already with this BA6137, and I'm going to create another duplicate circuit, just a replica of it for the other side. So what I'll do is I'll disconnect these LEDs from this board, and I will route them through to a new board that I'll make. So this is the circuit. This is what it looks like. So it's very simple. You've got a 5 LED VU meter here. There's the 5 common anode LEDs. Except in this circuit, there's duplicate. There's 2 LEDs. So that in series there's 2 instead of 1. But I'm just going to reduce that down to 1, and then I'll reproduce this one. And there's just a handful of other components on there, so that should be fairly easy to do, and I think it's going to create a better display at the front. I don't like, you know, if it's mirrored like that, you might as well just have one set of LEDs rather than 2. I don't like the way that it's just doubled up. I've just redrawn this circuit diagram just to show you how the inputs arrive at this board. So what we're going to do is we're going to split out the left and right signal. So the way that these are combined on the main board in the boombox, they run through these two 33K resistors, and all the components on the board are labelled. If it's a common component that's not left and right channel specific, then it doesn't have the R or the L after it. But any components that run through the signal path for right and left channel, they are labelled R and L at the end to make it easier. So these two 33K resistors, the signal is basically split off just after the op-amp. So in between the op-amp and the power amp, they go through these two 33K resistors, and then they're combined here, they're joined, and this is where the signal paths are combined for this single level meter. So what you need to do if you're doing this same modification is basically just break one of these 33K resistors from the circuit. So what I've done on this left channel here, I've just broken it here and lifted up this resistor on the board, and then I'm going to copy basically everything that's after that for my second level meter. So I'm keeping one intact. The right channel is intact the way it is at the moment, using the board that's already in there, and then from this point onwards I'm going to recreate all of this. And I've got the components here. It's just a handful of components you need to do to recreate that. So I'll go off and make this board now, and we'll try it out. So we're back with the circuit that I've made. This is it here. So all I've done is take off from the main board here the power, the ground, and the signal input. So as said, the signal input is taken after this resistor for the left side. So this is the left channel, and the right channel is just wired up as it was before. That's not touched. So if I now input a tone into this, we've got it on both channels here, and this is the input to the boombox. So if I disconnect the left channel, we now see that we've just got the right channel showing, and the same if I disconnect the right, we see it on the left. So we've now got a stereo level meter, which I think is going to look better. So what I'm going to do is put this back into the machine. I'll find somewhere to mount this behind the front grille, and then the next thing to do will be the Alexa LEDs. I'm going to fit those into the device. Connecting the line output from the Amazon device into the line input on this boombox. The line input is these two phono plugs here. It is really easy. We just need to take our 3.5mm jack lead, which is this one. This will plug into the Amazon device, and then the other end of this cable, we just need to strip off the wire and solder it to the back of these plugs. I think I might solder it underneath onto the circuit board, but it doesn't matter as long as it gets to these two plugs, because this is the way that you would connect up the device. If you had a 3.5mm jack to phono lead, you would just plug them into these inputs here. So stripping the wire and soldering it internally, that just reduces all the cables. You don't need to plug anything into the back, and it also gives you the option, if you want to still connect an external source. If you had an external audio device that you wanted to run on these phono plugs, you could quite successfully just plug those in and run those alongside the Alexa also being plugged into that as well. It might have some attenuation slightly on the signal, but it's going to work. So yeah, that's definitely what you need to do. Just solder them onto the other side of these plugs is probably the easiest, or you can solder them directly underneath onto the circuit board. Then the 3.5mm jack plugs straight into the Amazon line output. I've thinned out the wires on this board, so the red line and the blue line, the ones that we're not using, I've snipped those cables out. So we've just got these small bunch of cables now for the LEDs. I've decided, I was saying that I wanted to use red LEDs to match the red LEDs that are on the front here, to match these red level meter LEDs. I'm thinking now that if I'm putting red LEDs for the Alexa and red level meter LEDs, that it's all going to get confused. If everything's flashing all at once, it's just going to look like level meters. So I've decided I'm going to use blue LEDs. So I'm still going to run them off the green channel, so that when the original Alexa green LEDs lit up, I'm going to have the lights on the front, but they're going to be blue. So I'm thinking that would just look a bit different from the level meter, and you'll be able to see right away that that's something different. So I've ordered these blue LEDs in here, 3mm blue LEDs. So what I'm going to do is I'm going to solder those onto a circuit board and mount that behind here. So I'm going to drill some holes, very similar to what it's got at the moment. These holes, I'm going to put them there. I was going to put them at the edge, but if you look at the other side, there are some clips there which the top section of the box fits into, so there's not really enough room there. So the only place which is going to lend itself to these is this bit here, so there and there. So I'm going to drill 6 holes here, 6 holes here, and then I can mount the circuit behind. The speaker's going to go here, of course, over the top of there, so I need to just make sure that there's enough room. But once I've done that, I'll come back and show you what I've done. I also need to solder in some wires for the switches. So on the back of here we've got 4 tactile switches, which are the controls for the Alexa. Now these aren't going to be used all the time, these are only used if you want to repair the device, or there is manual volume controls on here, but we can just talk to the Alexa and tell it to increase the volume. So these aren't going to be used very often, so I'm going to put some wires on here and just mount some switches probably around the back of the unit, just in case we ever need to access them. One other thing that I need to sort out is the brightness of the LEDs. So there's this little device here, I don't know if you can see it, this camera isn't good at close-ups, but there's a tactile button there, the gold tactile button, and right next to it there's a small device. I'll put a picture up on the screen, but this is actually a light sensor. I'm not sure exactly how it works. It looks pretty complicated for a light sensor, but if you cover this up during operation, then the Alexa thinks it's dark, and it decreases rather the brightness of the LEDs. And then during daylight or bright light, it increases the brightness of the LEDs. Now I want the LEDs to be on full brightness all the time, so I'm going to need to figure out a way to fool this into thinking that it's bright all the time, or whether I can just take this off altogether, or whether I can bridge something out. I don't know. I mean, at the worst case, I could put a light over this, put a white LED or something to shine on it to increase that brightness, because of course this is going to be inside the box, it's going to be dark. So yeah, that's something I need to try and figure out. I'm almost ready to mount this into the boombox now. So all the wiring is done. We've got the LED wires, which you've already seen. I've also soldered wires where these switches were, so the tactile switches, I've just taken off the tactile dome and soldered them onto the center position. And there's also a common wire. I've also taken the LED for the mute here, so this is the mute switch, and there's 2 red LEDs on this board which light up red when it's on mute. So I've just taken 2 wires off there for the mute LED, so I'll mount that somewhere on the box. So that is all the wiring done on this, and it's ready to mount into the box. Other things that I've done are I bought this power supply. This is just off eBay, just a cheap USB power supply. It's 12 volts to USB. So this is a micro USB, so I can plug that straight into the Alexa. And I've just connected that to the power supply board here, the main 12 volts. So this is when you turn the power switch on, there's 12 volts output on this wire, and then off to this power supply. So that's quite neat. To show you the front panel that I've done. So decided to put the LEDs here. So there's a row of 6 blue LEDs on each side, and I've put them in the edge here. I think it looks quite neat there. There wasn't enough room to mount them where I was thinking of at the top because of the speaker inside. It just wasn't enough room. It would have been a bit cramped, but I think this looks pretty good there. Just got a small circuit board just glued on the back there, holding those in place, so those wires are ready to solder onto there. And just while I've got the front there, this side piece here, which is, it's meant to look like a port, I think, on the side of this box. It's actually blanked off. There's you can't. There's no air going through this. It's just a solid piece of plastic. But I'm thinking I might mount the Alexa board behind that grill. So inside, what I'll do is I'll cut an opening in this side piece, so it is actually open, and then I can mount this on the side there like that. And this should serve two purposes, hopefully. One is it will allow the microphones to be able to listen to voices. The microphones, as I showed you earlier, the microphones are here. There's 7 of them on the back, but the sound actually arrives in from this side. So these little holes you can see, this is where the sound is picked up. So I'm thinking if I cut the slot in the side so it's open and then mount this, then the sound hopefully will get directed to this board. The second thing that I'm hoping it'll do is this light sensor that I was trying to figure out what to do. If I mount that so it's orientated towards the hole on the side, I'm hoping that'll pick up a bit of ambient light, and then it'll still work as a light sensor. So in pitch black or dark room, the LEDs will fade and not be as bright, and then hopefully when it's light, the LEDs will be bright again. So that's the plan. What else? This is the inside of the Alexa Echo Dot. This is a Gen 2 Echo Dot, and it comes with this metal piece in here. This is aluminium, and it does have a heat spreader pad on there which makes contact with this. So the CPU is under this metal box, and it does get warm to the touch, but I don't think it's hot enough to warrant a heatsink. I was in two minds whether to mount this inside or not. So that would go there like this, and then because of this flat flex, that goes into the top board, and it would have to sort of sandwich together like this. So I'm not sure what I'm going to do yet, whether I am going to put it in like this or just these two boards together. I mean, it makes no difference really in terms of space. There's plenty of room. It would go here on the side, so there's plenty of room there, and it would miss the speaker. So yeah, let's see what I'm going to do with that. I don't know yet. If I can get it all together in this and sandwich together quite firmly, then yes, I think I'll put it in with the heatsink, but I don't think it needs it. You know, I've run it for a couple of hours and touched it, and it's warm, yes, but it doesn't get hot by any means. So that's it so far. So the next thing to do, I'm going to cut the slots in the front grille so that the sides are open. I might do both just so that it looks right, or I might just do this one. Again, don't know. I'll do this one first. If it's noticeable, I might cut the other side as well. And then I'll mount this into the side, wire up the LEDs. So this bunch of cables here, I need to wire up to my front panel. Also the switches, I've not sourced any switches yet, but I'm just going to order 4 probably small tactile switches just for the back or the side or somewhere, just in case we need to press those. And the mute LED somewhere, I might hide that behind the grill at the front. And then once I've done all that, I will come back, and then we'll hopefully see it all together and see it working. I was able to get the Amazon Echo Dot back in the original case, which has helped because I'm able to glue this then into the side quite successfully. It fits quite nice in the side there, and I've just put some glue on these top and bottom posts. I mean, if you were doing this yourself and you were using a different boombox, you'd have to figure out somewhere to mount this. I mean, with the microphones, it does need to be able to hear the sound outside. So if you didn't have any grills or spaces on the side, you could just drill some holes and mount this inside somewhere. There's a grill at the back of this, so it could have mounted in the back there. There's some grills along here as well, but I've used this side piece here. So what I've done is, I don't know if you can see that, but I've opened up this grill on the side. When that's over this Amazon, it's going to direct the sound from this port into this side of the Amazon, which is where the microphones are. So this has worked out quite well, that position there. I've also mounted the mute LED. It's hidden at the bottom there behind the grill. So when the mute's on, that's going to light up. Switches are being fitted into the back of the case. These are just the 4 buttons that were originally on the top of the Echo Dot. So they're just mirrored in these 4 buttons here. So we've got the selector button, we've got the volume plus, volume minus, and the mute button. And all I'm using here is some momentary action single throw tactile switches. All you've got to do is make sure that these come with different lengths of button, so you can order them in various lengths. This button here, so just need to measure whatever boombox you've got, whatever the outside wall is, and order the appropriate switch. And it's just a question of drilling a hole and gluing that in place. So I think they look okay. I am going to label them up. I just haven't got anything to label them with at the moment. This is now complete, so all that's left to do with this is to fit it back together. Last look inside here, there's the board for my left-hand channel level meter on the front. This is the connection for the other level meters and the operation LED. This little board here is the mute LED. These 2 boards on the end, of course, they're the blue LED strips for the Alexa, and the power supply there for the Alexa itself. You've already seen that where this is placed on the side here. So let's get this reassembled and you can see what it looks like. I'll show you this powered on now. So when we turn the power on, the Alexa will go through its startup routine. So if you remember what the LEDs looked like before, they were originally a blue ring with a green flashing light going around them. Now, as you know, the green channel is now on these blue LEDs. So what you see here is it's just coming from that blue channel that we've taken off the Alexa board. So we'll switch on. So this, if you can imagine, this is in the ring now. It started from one side, going around the ring and back to the start again. So I've reversed this side intentionally so that it looks like it's a continuous flow around, just like the original ring was. So that's the startup complete. And we can use this in exactly the same way as the boombox was intended. We can use the cassettes, we can use the radio, but when it's on the line input, we then have access to the audio out of that Alexa that's in there. So if I now say the wake up word, which is Alexa, we can see now that it springs into life. And these flashing lights here, where they're randomly flickering, so on the Alexa, it would, on the ring, it would show you which direction the voices were coming from. Because it's got 7 microphones, it's able to tell which direction that voice is coming from and light up the LED closest to that microphone. Of course, in this situation, it's not going to do that. They may flicker as it picks it up on different mics, but there's nothing directional about it. It's just going to receive all of its incoming sounds through the one side here. So let's turn the volume up. And we can ask something. Alexa, what's the value of pi?
The approximate value of pi is 3.14159265358979323844626. Yowza. This goes on forever.
And you may have noticed there that the level indicators are coming back in stereo due to our modification that we put in there. In fact, let me quickly connect an external line input and I will just show you a quick channel demonstration. So I've got a channel test running now.
Right channel. Left channel. Right channel.
So that looks better than before. I do like that that is stereo now. And we've got this fully integrated. So the buttons on the back, like I said, if I press the selector button, it's just another way of waking up the Alexa. You can press that rather than saying the wake up word. And then we've got the volume up and down. So it's on maximum volume at the moment, indicated by the LEDs. If I press the down button, and we can see the level drops. Okay, and then finally the mute button, and that puts the mute LED on here. So that is a mute on the microphones. So saying Alexa doesn't do anything now whilst that mute light is on. Alexa, play Spotify.
Okay, here's Spotify.
I have got a couple of other ideas that I'd like to do with this boombox, perhaps not this particular one, but one very similar. One of the things is that I would like to incorporate some tweeters into this, some high frequency speakers. This box at the minute has a bass speaker for the low notes, and then it has a full range speaker here, which is all the way up to the high notes. Now, full range speakers do have a tendency not to be able to reproduce those very high notes, as well as a dedicated tweeter. Now, the space available here is 20 millimeters, and it looks as though this was designed for a tweeter in mind. This isn't just a cosmetic indication on the outside. There's actually, I'll show you a picture, but inside it looks like it's got little fingers where it could clip in a small tweeter, maybe a piezoelectric tweeter, maybe a small dome tweeter, I don't know, but 20 millimeters isn't a great deal of size to get a speaker in there. So I'll have to experiment, see if I can find a speaker suitable that will go in there, and then also do some testing and see if it does produce some higher output notes for that frequency. The other thing that I'd like to do with this is to fit a rechargeable battery pack. Now this does have the battery compartment, which is still fully functional, takes 8 D-cell batteries, but I'd like to replace that, whether it's in the battery compartment or whether it's in some space inside, with a rechargeable lithium ion pack that we can charge up from the mains. So that would be a useful item to have in here as well. But for this one, we are now complete. It's been a bit of a long video, but I hope you've enjoyed it. There's been a few things in this which have been interesting, I think. So if you've liked the video, please hit the like button for me and subscribe if you haven't already. Thanks for watching. I'll see you on the next one.